rectangle.
Good morning, everyone. Thank you for joining us today. I'm Steve.
And I'm Scott.
And together we are Backyard Musings of the Science and Technology Channel. Hope you enjoyed the yesterday afternoon Zealandia, the continent where there are 8 continents now that we know of now.
Right. No longer a microcontinent.
Right. Okay. Advances in non-acoustic submarine detection could undermine traditional stealth advantages. Technologies exploiting magnetic field disturbances, bioluminescent organisms, submarine-generated waves, and thermal anomalies. I gotta slow down. And laser detection offer adversaries new tools to detect submerged submarines. A significant essay from the Navy Submarine League called Non-Acoustic Means of Submarine Detection analyzes several key non-acoustic detection measures that are improving rapidly and are likely to be implemented by potential adversaries. Would you like to know more? I'm interested.
Yeah, this is pretty cool. Unlike surface ships or aircraft more easily detected by satellite surveillance, enemy radar, and line-of-sight detection technologies, submarines can quietly and secretly lurk in high-threat areas to hold enemies at risk without being easily detected. Sonar systems and acoustic detection will likely be here for decades into the future, yet a series of non-acoustic detection technologies may be changing this equation. One central area of exploration relates to detecting disturbances in Earth's magnetic field, something devices can measure.
Yeah, so this was a triad: submarine, air bombers, and missiles from the silos, the triad for nuclear deterrence. Submarines were an important part of it.
Yeah.
And now we can detect them.
Yeah, because they're stealthy, like you said, right?
Yeah.
They can sneak up and
be on target for a long time.
Yeah. So it's this is cool, and they can be down under for a long time, right? Down under the water for a long time.
Yeah.
As we talked about before.
Quote, as a large piece of ferrous metal, the steel-hulled submarine causes a local disturbance in the Earth's magnetic field, end quote, the essay explains. The essay explains that if a submarine is built with non-magnetic materials, which that could be a possibility, its signature is decreased, but not eliminated entirely. Quote, submarines contain a large amount of metal, like the pipes and stuff, and the torpedoes and
electronic equipment.
Decking.
Yeah.
That becomes magnetized in the course of normal operations. The permanent magnetic field associated with the submarine remains until active measures are used to demagnetize it. The Naval Submarine League essay explains. The U.S. currently deploys 2 types of MAD equipment on its ASW. I think that might be magnetic something, demagnetizing thing. On its ASW aircraft. The essay says these systems can detect the submarine magnetic field at no more than a few thousand feet. So you've got your plane. Your plane would have to be going pretty low in order to detect something that's deep enough.
Yeah, because submarines, they go deeper than a couple thousand feet.
Yeah.
But other threats to the submarine are also possible. There are bioluminescent organisms beneath the sea that generate a natural light, something submarines can detect. This detection possibly is caused by boundary layer phenomenology. Sorry, I should know that. Referring to the water flow surrounding a moving submarine. This water movement generated as the submarine transits the undersea realm can also generate movement of undersea organisms, including ones that create detectable light. Quote, these organisms can generate light when they are physically stimulated in the boundary layer of a submarine or in its wake. This phenomena has been studied as a method for detecting submarines from the air or space, the essay explains.
Yeah, that's pretty interesting.
Yeah, so it's kicking up a little bit of dust, right? A little bit of sea dust.
Exactly.
Like when you're blowing across a dirt road or something, but it just happens to be under the water. Yeah. Interesting.
Another method of non-acoustic detection pertains to somewhat self-evident or easily observable variables such as submarine-generated waves on the surface of the ocean. I would think that would be, you'd have to be close to see a wave coming up. It would have to be close to the surface.
Well, it's the physics thing, right? If there's something moving under the water, it's going to generate some kind of a wave. It's like dropping a pebble in the
Yeah.
the rings of the pebble just keep going out and out and out until they find something to stop them, shoreline or whatever. So yeah, it would be the same thing, right? You just wait, follow the patterns of the wave,
The patterns.
Yeah, that's just kind of crazy.
When submarines move at shallow depths or travel at high speeds, they generate detectable surface waves. However, larger wind-generated surface waves can obscure or hide these waves. Internal waves of great significance generate surface signatures that are not visible to the human eye. Radar systems, however, can detect some changes in moving surface water generated by undersea oscillations and water movements caused by submarines. However, much like surface wind, there are many reasons why water can move beneath the surface. So there are also some limitations to this kind of detection method.
Also, not surprisingly, thermal sensors can detect small changes in the water temperature caused by submarine movements, like how an infrared sensor would detect a heat signature emitting from an enemy fighter or engine vehicle. Temperature detecting technology can quickly discern differences likely to indicate the presence of a submarine. Quote, a moving submarine may also change the temperature of the sea surface by mixing lower, cooler water with upper water, thereby leaving a trail of cool surface water that can be detected with infrared heat sensors, according to the essay. The problem with this is that whales also produce a neat signature. So,
yeah, so you combine that with the waves and then this detection of the heat. That could be,
Yeah, so I'm not a sonar or radar expert, but like when these guys are under the water already and they're detecting another submarine or something floating in the water or whatever, it's like bouncing energy off of that, right?
The acoustic, it's like a sound,
right,
like a wave, boom, boom.
Yeah,
but that can be detected by the enemy's sub.
Correct. Yeah.
Yeah.
So yeah, I don't know. This is fascinating too.
This is where it gets interesting. The Navy Submarine League essay further explains that laser detection may emerge as the most promising area of non-acoustic submarine detection. Overall, electromagnetic signals have little ability to travel underwater except in some ultra-low frequency waveforms.
So lasers underwater.
Yeah. Yet the sea is transparent to blue-green light. I guess it's not to red light, which electromagnetic light pings from a laser can detect. The sea is relatively transparent to blue-green light. A burst of blue-green laser light could penetrate the sea, reflect off the object, and return to the sensor. The round-trip travel time of the laser burst indicates the depth of the object, but cannot discriminate, for example, between a large whale and a submarine, the essay says.
Since the speed of light is a known or fixed quantity and the length of travel time can be determined, algorithms can then discern the exact distance of an object. The travel time can be determined like a laser rangefinder on land. Once the exact travel speed and time are known, an algorithm can quickly calculate the distance. In these cases, a blue-green laser light might be able to see or find a submarine at specific depths. So yeah, so I mean the water is really not blue, right? It's kind of it's clear.
It's reflecting the
sky.
The sky.
Yeah, the atmosphere of the sky.
Yeah.
Or whatever is around it. Like if you're in a lake, you see the mountains, reflection, all that kind of stuff. So yeah, so that blue-green, I mean that must be from what stuff under the water that's creating that, I guess. I don't know.
Over my head, man. I don't know. If they say it works, they've tested it.
Yeah.
Yeah. So that's really fascinating.
Yeah, cool stuff.
Really cool stuff. So, I mean, subs are in for trouble if they can be detected with this laser,
That would not be good.
Not be good, yeah. Maybe they're going to have to make some funky, weird angles that make the laser light jump off. Like
a stealth plane or bomber.
Yeah, have weird angles on it. Yeah, that could defeat.
Or using a different material, like they were saying, maybe like a polymer, right? Or
a combination of that, like they do with stealth bombers. Yeah. All right, folks, thanks for joining us. Catch us this afternoon.
Right. Take care, everyone.